Hello guys, today we got this RTX 3070 that came in for repair. The customer stated that it's no longer detected by his computer, so let's confirm that's the issue. I just inserted the card into my PC and I hooked up the monitor to the iGPU so we can boot into Windows and open Device Manager to see if the card is detected there. And as you can see, it's not. Also, just to be sure, let's open hardware info and check if the card is even listed as device on the PCI Express bus. And as expected, it doesn't show up here as well. So now let's take it apart to have a look inside. I'll remove all the heatsinks and the I/O bracket so you can see everything on the board. At first glance, I don't see anything wrong, so let's take a closer look and some measurements. But before that, I'm happy to announce the sponsor of this project, PCBWay. They feature a variety of manufacturing services, including many types of rigid and flexible PCBs, CNC machining, 3D printing, and many others. That's why they can be the one-stop solution for our projects. From my experience, they provide fast services with exceptional quality and great customer support at affordable prices, which is ideal for rapid prototyping, so make sure to give them a try with your next project. Here you can upload your designs, specify your requirements, and get an instant quote for your project. Their PCBs start as low as $5 for 10 pieces and can ship worldwide. You can find the link to their website in the video description. Now the first thing that catches my attention is that the BIOS chip appears to be resoldered. So most likely somebody tried to reflash the BIOS in an attempt to solve the problem, which clearly didn't work. Let's leave this aside for now and take a few key measurements to see if there is a shorted voltage rail. So we take a multimeter, put it in resistance mode, and with one probe on ground, we measure on the inductors. And depending on the voltage rail, we should see a different reading. Let's start with this inductor here, which is PEX and should read about 10 ohms. And we have 11.8, which is good. Next we got the 1.8 volt rail, which should have about 1.5 kilo ohms. And there we have 1.4 kilo ohms, which is okay. Now we are at the 5 volt rail and I expect to see a couple of kilo ohms. Next we have the memory, which is usually between 30 and 100 ohms depending on the manufacturer. And these two should be the 12 volt input, where you expect to see at least a couple of kilo ohms. Lastly, I'm going to check the 12 and 3.3 rails on the PCI Express connector, which appear to be fine. I won't bother checking the resistance on the core because it's in the milliohm range and I don't have a milliohm meter right now. Now I'll plug the card into a riser connected to a power supply so we can check if all the voltages are okay. Now I see that there is one more voltage rail at the back and I didn't check its resistance. But all the voltages look to be alright, so the power is definitely not the problem here. Here is the board on the preheater, which is set to 220 degrees Celsius. It's a great idea to apply a generous amount of wax to the core before removing it, to prevent oxidation of the pads below. When the board reaches about 200 degrees Celsius, I turn on the hot air, which is set to 300 degrees and 100% airflow. Then I start occasionally checking to see when the solder will melt, and when that happens, I can use a vacuum pen to lift the core away from the board. While the board is still hot, I will apply a bunch of wax. Then I will go across all the pads with the soldering iron set to 380 degrees Celsius and some leaded solder to dilute the lead free that's on the board, so it's easier to clean up. Then for the cleanup, again using soldering iron and a piece of solder wick, I will go across all the pads, so there is minimal amount of solder left on the pads and they are as flat as possible. The key thing here is keeping all the pads under a layer of wax while the board is still hot to prevent oxidation and subsequent fail of the reball. When the board cools down to about 60 degrees, you can clean the used wax from the board. Then we can inspect the pads and trace the PEX reset line to check if it's continuous. And in fact it is. So the only possible cause for the issue I can think of is a bad solder joint that was under the core. Now we can clean the rest of the wax from the board. Now it's pretty much the same procedure for cleaning the core, with the difference being that you don't really need a preheater to do it. Unfortunately, while cleaning the bottom of the core, I've knocked some caps from the other side, so let me replace them before we continue. I'm going to clean the flux residue from the core, and then I will secure it in the rebow jig. For the rebow, I will be using this stencil, but instead of 0.5mm solder balls, I will be using 0.45, because that way it's much less likely to get nearby balls to stick together while rebowling. The first step of the rebow is to align the stencil with the chip. Then we secure the stencil in place and we lift it up from each corner, high enough so it's not touching the chip, but not a lot, as the solder balls should not be able to fit between the chip and the stencil. Then we take a small amount of preferably very viscous flux, and we apply a very thin layer of it onto the chip. That's usually the most tricky part, as there should be enough flux so the solder balls stick where they need to, and not all the flux evaporates before the solder balls melt to the chip. But at the same time, too much flux will cause them to float around and combine, instead of staying in place. For me personally, it's easiest to spread the flux with my finger. Then we put the stencil back and we pour the solder balls on top. Now, while holding firmly the two parts of the jig together, we can shake it a bit to distribute the balls. Then we can return the excess balls in the jar. Next, we check if all the holes have a ball in them, and if so, we can lift up the stencil. We can now take the core out of the jig and preferably put it on some kind of preheater or heat plate set to 200 degrees Celsius. The solder balls are 6337 leaded with a melting point of 183 degrees Celsius, so the heat from the heat plate should be enough to eventually melt them. But I can't wait that long, and so I will use a hot air set to 300 degrees Celsius and 10% airflow to make things happen a little faster. If you do so, please be careful with the airflow speed and the distance from the chip, so you don't blow away the solder balls from their places. After all the balls are seated, we can turn off the heat plate and wait for them to solidify before moving the chip. It's almost impossible to get a perfect reball, so here are some tips on fixing the common issues. First, you would want to fix the chip so it doesn't move around. Then you take a solder wick and cut it at an angle, so it has a pointy tip. Then you pick it up with tweezers, and using the pointy tip of the wick and a hot air set to 260 degrees Celsius, you gently touch the bowl or the bridge you want to remove. You want to remove as much of the solder as possible. Then you can put new balls on these spots one by one, again with the hot air and a pair of tweezers. Now, when all the balls are equal and in place, I like to let the core cool down and then put it in an ultrasonic cleaner with some isopropyl alcohol to get rid of all the flux. Here you can see how the core looks like after the cleaning. Now I can put the board on the preheater again and apply a relatively thin layer of flux. Though the thickness is not as critical as before, if you apply too much flux, the core can float around when the flux melts and you would need to start over. You can use a brush or something else to spread the flux here. Just make sure that all the pads are covered. Then align the core with the silk screen, turn on the preheater and again set it to 220 degrees Celsius. When the board approaches 170 degrees, you can turn on the hot air, which again is set to 300 degrees and 100% airflow. Here you can see how the solder balls melt and the chip kinda sits in place. Just to be sure, you can give it a gentle nudge to see if it will spring back. And also you can add some flux if you want. When you are sure that all the solder has melted, you can turn off the hot air and the preheater and let the board cool down. Lastly, before assembling the card, I will put in the ultrasound for final cleaning. Now I want to thank my patrons Michael and James the Mod for their support. If you too want to support the channel, you can find link to my Patreon in the description. Also, if you want to send something for repair or upgrade, you can fill out the mail-in form. Lastly, you can find links to most of the tools I use in the description. Now the only thing left to do is to put it in the computer and see if it works. As you can see, we got a picture and the drivers have installed successfully. Also, the card is recognized correctly in GPU-Z, so I guess it's time for a stress test. Temps are looking good, there are around 10 artifacts, so I'll call this repair a success. That's it for today. As always, thanks for watching, till the next time, bye.